All right, let's go ahead and find out or figure out how to calculate some of these inverse values. So example 2, suppose f and g are inverses. So if f of 6 is equal to -8, then g of -8 is going to equal what? Well, we're going to go back to that definition and pay real close attention to how the point structure went. So to go from a function to its inverse, you just flipped the x's and the y's. So that's basically what they're doing here. So then for g of -8, it's going to equal that value of 6, which is kind of cool. Like, as long as you know their inverses and you have a point of one function, you automatically know a point of the inverse without having an actual equation. Okay, let's try it again. B, if g of root 7 is equal to pi, then f of pi is equal to root 7. C, f of g of -2. Well, that is just going to equal -2. Because that's using that composition stuff. So what that's really telling you is that if you do a composite of a function and its inverse, the function and the inverse essentially cancel each other out, and you're left with like your x, or whatever number has been plugged in there for x. So it makes those kind of fun too. So for D, g of f of e squared, well, we know they're inverses, so they're going to cancel out. And we're left with e squared. And then part E, if 6, 9 is a point of f, then 9, 6 is a point of g. All right, not too bad. Okay, so that's how you can kind of play around with some of the values. Example 3, and then in the next example, we're going to look at how to find the inverse of the actual function. So first things first, if it's not already done, if you have f of x here, or g of x, or h of x, just change that function notation into a y. Okay. And sometimes it's done for you, so you don't have to do this, but if it starts this way, great. If not, just change that thing into a y. All right, the next step is now you're actually going to flop and switch places between the y's and the x's. So every y becomes an x, and every x becomes a y. So you're just trading places. We haven't like started to solve anything, you just traded places. So once you trade the places, now you can start to solve for y. And once you have the y by itself, then you're done, and that's your inverse. So there's a lot of ways to go. Just depends on what type of equation you're solving. So with this one, let's treat that as like x over 1, because then we can just cross multiply it. So that would be xy minus x is equal to -2y. And again, we're solving for y, so I need all my y's on one side. So let's move this -2y over to the left. And if it doesn't have a y on it, so like that -x, I'm going to move it to the opposite side. So let's move it to the right side. Okay. Now let's go ahead and pull off the y. And then to get y by itself, just divide by the stuff in the parentheses. So y equals x over x plus 2. And that is your inverse function. So then you could say, hey, the inverse of f is equal to x over x plus 2. All right. Okay, let's go ahead and try that again with the next example, example 4. Just because it's a different type of function. So again, my first step is I'm going to change that g of x into a y. I'm going to leave everything else alone. Oops. Which means I got to leave the 1/2 in there. And then I'm going to switch places with the x's and the y's. So now I have x equals 1/2 times the 5th root of 3x minus 7 pi, or sorry, 3y minus 7 pi. And now I can try to solve for the y. So first let's get rid of the 1/2. Just get rid of that fraction. So let's multiply everything by 2 to both sides. So we've eliminated the fraction and we have the radical by itself. So now to get rid of the radical, I'm going to raise everything to the 5th power, or both sides to the 5th power. So my left side I have 32x to the 5th. The right side over here, the 5th root and 5th power cancel. So 3y minus 7 pi. And then just solve for y. So now I can add 7 pi to both sides. Can divide both sides by 3. And there's my inverse function. So that would be g inverse of x equals 32 x to the 5th plus 7 pi all over 3. So that's how you can find the inverse of a function. So now let's look at the graph of the inverse function. All right, so here's your original function, and we're going to graph the inverse. Well, remember that from going from the function to the inverse, you just have to flip-flop the points, or flip-flop the coordinates. So let's just do that. So 0, 0 stays as 0, 0. The next point is 1, 4. So we're going to flip that to 4, 1 and plot it. Okay, your next point was 4, 7. So that's going to flip to 7, 4. And then your last point, which is 10, 9, we'll switch that to be 9, 10. And now we're going to connect the points with the same type of connection that was existing from the function. So in the function, it was just like line segments. So we're going to do the same thing for the inverse. And there you go. So part B, even though it's a curve, we're still going to approach it in the same way. So the first point is -2, -4. So that would mean it's -4, -2. And I messed up when providing the graph because I didn't make it quite big enough, so we're just going to have to pretend. We'll say that's -4 out there. So -4, -2, 0, 0, and then 2, 4 becomes 4, 2. And we need to curve it in kind of the same way. So don't like curve it like in the same direction. It's actually going to go like that. So there's your graph. So then the last part of the question says, well, what do you notice about the graph of the inverse compared to the graph of the original function? So from going from a function to its inverse graph, it has the neat little property that they're symmetric about the line y equals x. So this one worked out really nice visually because it was the x and y was to scale. This one, it's still symmetric about that. It's just it looks weird because the x's are a little bit wider than the y values. Like the spacing is not great. So I apologize for that. But there you go. Okay, go ahead and try the homework and let me know if you have any questions.